Okay, let's talk about each one. Of course, when you're doing a problem like this, you're definitely going to find the total first. That's what we always do, is we add up all of our items in our sample space. So in our sample space, there are 12 items. And then you put, so 12 goes in our denominator, and then we're going to put how many of those items are favorable. 5 are favorable because we want to draw blue, and there are 5 blues. You always reduce your answer, but 5/12 is not reducible. Green or yellow. Now, we still have 12 items in our bag, but we want to choose a green or yellow. So you take the number of greens, you take the number of yellows, and you add them together. So between green and yellow, there are 3 of them. We would never answer 3/12. We would definitely convert it, reduce it to 1/4. And then for the ones that are not red, there's 2 ways to do that. The ones that are not red. So one way to do that is to count up all the ones that are not red. So 5 plus 1 plus 2. And you could get 8 out of 12. And you can reduce that, right? Did I add them up correctly? 5, 6, 7, 8. Okay. And then you would reduce it. Or not choosing something is also called a complement. And I didn't officially go over that yesterday, but I kind of assumed you would figure out yourself. Finding the complement of a probability is when you find the probability of something happening, and then you subtract it from 1. Because if the probability of something happening is 1, then it's certain to occur. So you would find the probability that it's red, and you would subtract it from 1. So 1 minus the probability of drawing a red. Does that make sense? So when you see that word not, it's called a complement. And you can simply subtract the probability of it happening from 1. It's called finding the complement. So you can go about either of those 2 ways. 4 out of 12, that's 1/3. So 1 minus 1/3, and that's how we're getting 2/3. Either way. You're welcome to work it either way. Here are the homework answers. Once again, it's pretty hard to see, so I will walk you through each one. This one is 0.17 or 94/564. This one is 0.67. This one is 0.83. I'm wondering, did y'all put your answers as decimals or fractions? Because you might have to convert these if y'all's are a fraction. Number 2A, 76/608 or 0.125. Part B, 0.75, so 3/4. Part C, 1 minus 0.125 or 0.875. Number 3, experimental. Number 4 is C, and number 5 is H. What can I go over from this first day? From this first page. Number 5. Will not want multiple choice questions. Will not want multiple choice questions. So you take 1 and you subtract the probability that they will want multiple choice questions. So the probability that they will is 35 over, I don't even know the total. Is it 40? The total 40? No, it's way more than 40. What's the total? 120? So if you do 35 divided by 120, math, enter. If you reduce that, that's 1 minus 7/24. So that's what I was saying in the warm-up. If you want something to not happen, you find the probability that it will happen, and you subtract it from 1. Because all probabilities are out of 1. Because, where did I get the 1? Because 1 is the highest thing you can get. For example, if I told you something had an 80% chance of happening, It's got an 80% chance of happening. What's the chance that it doesn't happen? What would you do? 100 minus 80. You would take the total, like the max, and you would subtract. So the chance that it does not happen would be 20%. It's the same thing for fractions. If the chance that it will happen is 1/4, the chance that it won't happen is 1 minus 1/4. 1 is the highest probability you can ever get with fractions when they're in fraction form. So 1 is the probability that it's absolutely certain. So you take the probability that it will happen, subtract it from 1, and that's the probability that it will not happen. On to the back. Number 1, 4 out of 11. Number 2, 1 out of 36. Number 3, 1 out of 15. Number 4, 2/3. Number 4B, 1/3. Number 5, 1 over 35. That was one that you really had to think about. It was a lot like the ad one that we did in the notes, the DJ and the ads, and they're playing their ads on the radio. Number 6 is 9 out of 16. Number 7, 2 out of 19. Number 8 is 12 out of 19. 7 out of 19. And 14 out of 19. So which ones can I go over of these? Thank you for asking. Number 2. When two number cubes labeled 1 through 6 are rolled, what's the probability the result will be 2 4s? All right, so take the first dice, the first die. What's the probability that it'll land on 4? You have a 1 in 6 chance because there's 6 numbers and one of those numbers are 4. Then, on the other die, you want it to happen again. A 1 in 6 chance. So you just multiply them. 1 times 1 is 1, and 6 times 6 is 36. You have a 1 in 36 chance of getting both 4s. Okay. What else? Can we do number 6? Yep. Find the probability that a point chosen at random inside the large circle will also fall inside the small circle. So what you're going to do is you're going to do the area of the small circle over the total area. So you put what the favorable outcome goes on top and the total possibilities go on bottom. That's how you find the probability of anything. So the area of the whole circle is pi r squared. And the area of the favorable circle is pi r squared. The pi's cancel. 3 squared is 9, and 4 squared is 16. What else? All right, number 5, because a lot of you said that you were having problems hearing me yesterday, and if I didn't post the recorded lesson, then you couldn't have watched it. So you probably missed out on this example. So let's go over this one. So she's got 7 CDs. 3 of them are classical music, and the rest are pop. She's got an interesting taste in music. So she's going to close her eyes and grab 3 CDs, and what is she doing? Taking them in the car with her. What's the probability? She's going to select all 3 ones that are classical. So it's not going to be a very big probability because she's probably going to grab a pop music in one of those 3. But anyways, let's talk about the numerator and the denominator. I always do the denominator first because that's just saying how many choices are there. So if she's got 7 CDs and she's going to pick 3 of them, this was day 1. You're asking yourself, how many ways can I choose 3 CDs out of 7? So we did this on day 1 of probability. So the way that we do that is 7, choose 3. How many ways can I choose 3 out of 7? Order doesn't matter because she's taking these CDs with her to her car. It doesn't matter which one she pulls first or if she pulls them all at the same time. So since order doesn't matter, the denominator is a combination. It's not a permutation. All right, so you always put favorable over total. favorable over total. How many CDs are favorable? How many are classical? 3 are favorable. How many does she need to choose of the favorable ones? She needs to pick all 3 of them. There's 3 favorable and she needs all 3 of them. So it's actually 3 choose 3. But you can also think about this as 3 choose 3 is just 1. If you have 3 CDs that are your favorable and you want to choose all 3 of them, there's only one way to choose all 3 of them because the order doesn't matter. So it's really 1 over 7 choose 3, which is 35 when you put it in your calculator. Yeah. Anything else, guys? Move on to today's lesson. Last lesson of probability, independent versus dependent events. All right, so you are tossing a coin, and you toss it 3 times. Now, whatever you got when you tossed it the first time, does that affect what you get when you toss it the second time? No, right? That's what's called an independent event. So whatever, if I land on tails the first time, that is not going to affect what I land on the second time. It's like your memory gets wiped clean. You start all over the second time. Then you start all over the third time. So events that are independent means that the first event does not affect the next event. Now, a dependent event would be like a bag of M&Ms. You choose a green one out and you eat it. Now the probability of choosing another green one is different than when you started the experiment. Who can give me another example of an independent event? Give me another example besides tossing a coin. Rolling a dice over and over. Very good. Whatever you roll the first time has no effect on what you roll the second time. You start all over. A spinner. Very good. You spin a spinner and it lands on green. That has nothing to do with what color you will spin the second time. Okay, give me another example of a dependent event that has nothing to do with candy. You're not allowed to use candy. Good. What do you think? A dependent. Eating marshmallows without replacing. That's the same as M&Ms. Pulling a card out of a deck and not replacing it. Yeah, very good. Okay. So, I've got some events right here. We're going to drag the situation to the correct column. I'm going to read all of them first, and then I'll let you request control, and I'll let you drag them. Picking a red, then a blue, then a white sock from a drawer to pack in a suitcase. Selecting 2 face cards when the first card is replaced. Selecting a white bead, not replacing it, and then selecting a red bead. Probability that Sarah will get a blue gumball after Chris and Mario get green ones. Okay, Jenny. Oh, Austin's is the only one showing up, Jenny. And Yeji's is showing up. Jenny, where's yours? Jenny, request again. I can't see it. The probability that Sarah will get a blue gumball after Chris and Mario got green ones. When you get a gumball out of a gumball machine, you don't put it back in there. That would be gross. So you get the gumball, you put it in your mouth, you start chewing it. That's going to affect what gumball the next people get because now that gumball is no longer in the machine. All right, Austin, you're up. Hussein, I see you next, okay? Austin, if you don't do it, I'm going to give it to Hussein. Selecting a white bead, not replacing it, and then selecting a red bead. Try again. You're not replacing it. So you have that white bead in your hand. The probability has changed. Okay, I'll do it for you. It goes here. All right. Hussein, request again. Oh, Jenny, I gotcha. Jenny, you have control. Uh-oh, wait. Unclick it. If you're replacing the card, if you're putting the card back in the deck, then you're resetting your experiment. It's starting all over again, so it's independent. Very nice. Last student. Request control. Who's going to request? All right, I will do it. No one is requesting control. Picking a red and then a blue and then a white sock from a drawer to pack in a suitcase. So that one is also dependent because you're not putting the socks back in the drawer. When you pick them and pack them in a suitcase, you are changing the odds of picking that color again or any color because you've changed the sample space. All right. Example number 1. So some of our examples are going to be independent probabilities and some of them are going to be dependent. When you want more than one thing to happen, you multiply the probabilities. So if I want to flip a coin and land on tails and then I want to roll a 4, you're going to multiply those two probabilities together to get your total probability. Are those events independent or dependent? Independent, very good, because one does not rely on the other. So for each one, I always start with the denominator. What's the probability you flip a coin and land on tails? Well, there's 2 options, and one of those options is favorable. There's 6 options, and one of those options are favorable. So our final answer is 1/12. That was child's play, I know. All right, let's try this one. Probability of selecting a card that's a heart, then selecting a card that is black without replacement from a standard deck of cards. So there's a picture of a deck of cards. There's 13 of each suit, and there's 26 of each color. This time, what is the probability, independent or dependent? Very good, Albert. This is your key word. You're not replacing. So it is dependent. So that's going to affect how we solve this. There are 52 cards in that deck, so that is my number of items in my sample space. What's the probability I select a heart? How many of those 52 cards are hearts? Out of all 52 cards, 13 of them are hearts. Now, I do not replace my card. So now I've got that heart in my hand. We're assuming it's a heart. Now there are 51 cards in the deck. How many of those are black? Now since I have a red card in my hand, hearts are red. Since I have a red card in my hand, they're good. There are 26 black cards left. So then we just multiply them. 13 divided by 52 times 26 divided by 51. Math, enter, enter. 13 out of 102. Now sometimes when the fraction doesn't mean much to you, like I don't really know what that probability is, you can always take it and write it as a percent as well, because the percent is 12.7. Sometimes that makes more sense to us. Oh, I have a 12.7% chance of drawing a heart and then drawing a black card. We actually drew one, we did this last period, and they drew a heart and then they drew a black card. So they only had a 12% chance and they did it last period. It was cool. We're going to do those experiments tomorrow, so don't worry, we will do them. All right, what is the probability that someone voted for Bush in 2004 given that they were from our county? Probability that someone voted for Bush in 2004 given that they were from our county. Well, good. I'm glad. If you're confused by it, it's good that we're going over it. This is a dependent probability. You have to find out how many people voted for Bush, but it's dependent on the fact that they're from our county. Do you know what our county is? Do you know what our county is? It's Harris County. Yes. So, we are only looking at the people from Harris County. So what do you always do first? You always find a total. You add them up. You always find a total. 581 plus 472 plus 5. So 1,058 is the total. And then in the numerator, you put the favorable ones. How many are favorable? 581. I don't think that reduces. It does not reduce, so let's also write it as a decimal or a percent. What do you get when you write it as a percent? 54.9% is 0.549. So a little over half of the population in Harris County voted for Bush. Okay, so that's what the given that means. Given that means you only look at Harris County. You only look at our county. That's what the given that means. Last example. Yep. Last example. I'll let you think about it for a minute. No. Okay. The sum of the spins is less than 6, and the second spin is a 2. So, what I want you to think about this is, okay, there's two things that are happening. The trick to this one is that you need to find the second thing first. What's the probability that the second spin is a 2? Because they're saying it has to be a 2. This one's non-negotiable. So what's the probability that the second spin is a 2? 1 out of 8. Okay, so the second spin is for sure a 2. We got a 2. What are the different possibilities for this first spin to be so that the sum is less than 6? So what things can you add to 2 and get a number less than 6? Let's see. It could be a 1. It could be a 2. It could be a 3. It could be, oh, can't be a 4 because 6 is not less than 6. So on our first spin, we've still got 8 numbers on that spinner. That doesn't change. How many of those are favorable outcomes? 3. 3 outcomes are favorable. And on the second spin, only 1 outcome is favorable because it's got to be a 2. So you kind of have to work backwards on part A. So it's 3 over 64. Okay, next one. First spin is odd, and the sum of the spins is 8. So let's do the first one first. The first spin is odd. So what's our chance that the first spin is odd? You can put 4 out of 8, or you can go ahead and put 1/2. Doesn't matter to me. Half of the numbers are odd. The sum of the spins is 8. What do you think we're going to do for that second part? So your first spin is odd. Let's make up. What odd number do you want? Give me an odd number. Let's say we landed on 3. How many numbers? So we spun a 3. It's over. We spun a 3. How many different numbers can you add to 3 and get 8? Well, the only thing I can add to 3 is 5. The only thing that would be favorable once I spun a 3, the only thing that would be favorable is rolling a 5. That's all you can roll. Now pretend it wasn't a 3. Pretend it was a 7. You rolled a 7. How many things can I add to 7 and get 8? Well, a 1. I have to roll a 1. What's the chance of rolling a 1? Oh, it's still 1 in 8. So no matter what you roll the first time, no matter which odd number you roll the first time, it's going to be a 1 in 8 chance that the sum is 8 for your second time. So 1 out of 16. Fun, huh? Okay. All right, so we do have a quiz on Monday. Tomorrow is our probability play day.